another Leetcode problem, 76, minimum window substring. So for this problem, we are giving two streets S and T, and the length of them are going to be M and N respectively. So definitely we can calculate we can check the length of the street S and ST. So we're going to return the minimum window substring of S such that every character T is included in the window. So for example, B, A, N, C. So this is yeah, it's gonna be here, B, A, N, C. So inside this is substring. So let's check the substring is a contiguous, non-empty sequence of characters within the string. So this is a substring. So this substring include A, B, C. So and it is also the shortest. So we're gonna return the shortest substring. So the test cases will be generated such that the answer is unique. So definitely we know that the shortest gonna be unique. But how can we solve it? So basically, I think the obvious idea is that we're gonna use a counter, and we're gonna use a dictionary, and we're gonna use the sliding window technique to check. So for example, from A to D, O, E, B. Oh, currently we have A and B, and to C. Yeah, this is one, but it is not the shortest. So what we're gonna do, if we find, we include this street T, A, B, C, so we're gonna slide the window to here. Now it is not possible, so we're gonna extend the window to here, here, until we find A. Yeah, and then we're gonna, just make the window smaller to here. And then we're gonna extend the window to here. Currently we have AB, but we don't have C. Now what are we gonna do? We're gonna extend the window from the right side, from here, and then we're gonna make the window smaller until here. So this is gonna be the shortest substring. And it's gonna be the minimum window substring. So we're gonna return this substring. But how can we solve it? As I said before, I'm gonna use counter or dictionary in Python. So for S, it's gonna be a counter of empty counter, and for T, it's gonna be a counter of T. And we also need to use the left border. It's gonna be L, and our final answer gonna be the result. So here gonna be L gonna be the left border gonna be 0, and the result gonna let me check because it is the shortest. So we can prepare the result as S plus T, because that's gonna be much longer than string S or string T. So this is very important because we're going to prepare the final result with S plus T, because S and T going to be less than or equal to 1. So it's going to be longer than 3S. So this means if we find a substring inside S, it must be smaller than the length of S plus T. But if it is equal, this means we didn't find it, and we're going to return an empty string. So this is very important. So the result is going to be S plus T. Now we can use sliding window to check if that is possible to find one possible cases. So we're going to set each string inside S. So for IC, enumerate S, and we're going to prepare the counter. So we're going to update this counter, and we're going to have the while check. While S more than or equal to T, we're going to prepare the final result. It's going to be the result with string from L to R plus 1, and the key going to be the length. So this is to check which gonna be the longest string, and the final answer gonna be string. K is just a lambda function. It just tell us to check the string, this string and this string, but the final result gonna be string. Yeah. Now what are we gonna do? We just need to update the left border and give the final result. Yeah. But before we update the left border, we need to update the dictionary s. So for s, sl gonna minus equal 1. Yeah. Yeah. Basically, I think that's all about it. But let me just run it to check. Yeah. Here I'm gonna use the border, right border r. And if the result not equal to s plus t, otherwise it's going to be empty. So this is my final result tag if it is equal to s plus t. If it is not equal, I'm going to return the result. Currently, definitely it didn't work. Yeah, so this is the sliding window idea. Let me check what is wrong with it. So this is my dictionary, and I have two counters, and I update this counter, and untag. I'm gonna check if it is more than or equal to t. So currently, let me just figure out what it looks like. The counter s. Yeah. So inside the counter s, here we have 1a, 1b, and 1c. This means that it should be okay. Here because it is a minimum substring, it's not the maximum. Yeah, so this is my mistake. Yeah, because we are always calculating the minimum. As you can see, now it is okay. Now let me just submit it. Yeah, because we are calculating the minimum substring. Yeah. As you can see, it works. Yeah, so the time, it is okay. It is 1 second. But what about the follow-up? The follow-up asks us, could we find an algorithm that runs in O n plus n time? Is that possible to make it linear? So currently we are using this counter compared with another counter. So that is actually 26 characters plus another 26 characters and times the length of the string. It's going to be m. So this is going to be the final time complexity. Yeah. So this is 52 times m. It's going to be it's going to be a bigger value. But how can we make it smaller? We just want to make it m plus n. Maybe this t is really short. Yeah, but this m plus n definitely is going to be smaller than 52 times the times m. Yeah. We just need to change a little bit and make it better. So instead of that, we're gonna prepare a counter. The counter is used to count how many k's inside, how many k's we find inside the counter s, which is equal to the character inside the counter t. Let me just give you an example. So inside counter t, for example, for this ABC, we have A, B, C, and how many of them? It is 1A, 1B, and 1C. Now what are we gonna do? We're gonna check the coder S. So inside S, we're gonna check his character. If we find a character A, we need to have a count. So this is the use of coder. We need to count it to be 1, and then this means we find it. And then we need to count another B. It's gonna be 1, and C is gonna be 1. Yeah. So this means we already, if the counter equal to 3, it means we've already found 3 characters A, B, C, and all of them are working well because the number is, all of them, the number equal to 1. The number equal to 1, and this is 1, 1, 1, and this is 1, 1, 1. This means we've already found it. So while we are sliding the window, this may become 0. So this means the counter before it is 3, now it becomes 2. So it because currently it is not possible. So we're gonna continue to slide the window to find the counter to be 3. So in this way, we reduce the time complexity to m plus n instead of 52 times m. It's gonna be much smaller. Yeah. Now let's just use this idea to check. Here definitely we cannot use this. Yeah. So here we're gonna use a check if SC equal to TC. We're gonna update the counter. For the while check, we just needed to check the counter. If the counter equal to the length of counter T, this means we've already found it. Yeah, so we're gonna update the result, and we're gonna slide the window. But before that, we need to check the counter. If SL yeah, but how can we update the counter? Yeah, we're gonna update it from here. Here we calculate this character minus 1. So after minus 1, we need to check. So if SSL less than TSL, so this means if there's character, for example A, inside, before it's 1, now it becomes 0, so we're gonna update the counter. So the counter gonna minus equal to 1. I think now it should be okay. Let me just run it. Yeah, as you can see, it works. Now let me just submit it to check. Yeah, as you can see, it's possible of testing cases, and it's pretty fast. So compared before, it was like 1 second. Now it becomes like 0.2 seconds. So definitely reduce the time complexity, and this is a really good method. So instead of comparing directly with the counter, so we're gonna prepare a counter instead of this counter. So this is like dictionary, and we're gonna directly use a number to count. So we're gonna use this counter just as a number to check if it meets all the conditions, and directly we reduce the time complexity to O n plus n. I think that's all about it.